Okay, question 5. So it says, long-term experience shows that if it is sunny on a particular day in Vokram, then the probability it'll be sunny on the following day is 0.8. If it is not sunny, the probability that it will be sunny is 0.3. The transition matrix T is used to model this information. Part A, it is sunny today. Find the probability that it will be sunny in 3 days' time. Now you could draw a tree diagram, do sunny, not sunny, sunny, not sunny, and do all this, and there'll be lots of combinations, and you could work out the probability that way. But the nice thing about these transition matrices is you don't need to do all that. You can just do T cubed. So T cubed, let me create the matrix. So we have a matrix, create matrix 2 by 2. Let's put in 0.8, 0.3, 0.2, and 0.7. And I'm going to do this to the power of 3. And this gives me 0.65, 0.35, 0.65, 0.35, and 0.525 and 0.475, 0.525, 0.475. Now what these give us is the probabilities for, look, if this is sunny, let's say sunny, not sunny, and then sunny, not sunny. So this means, this column means if it's sunny today, what's the probability it'll be sunny in 3 days' time? It's this. What's the probability it won't be sunny in 3 days' time? 3 days' time, it's this. This means if it's not sunny today, this is the probability it'll be sunny in 3 days' time, and this is the probability it won't be sunny in 3 days' time. So that's what that's how we can use a transition matrix to find future probabilities. It's really nice little way to do it. But obviously I have to write down the probability. So therefore 0.65. It's this one. It's sunny in 3 days' time. But certainly write that to get your method mark. Okay, part B. Find the eigenvalues and eigenvectors of T. Okay, so this, guys, is what I would call not easy, familiar. So you're gonna probably get asked the question to find eigenvalues and eigenvectors. If there's a method to do it, I obviously have the video done in my lessons, and I'm obviously going to do it here. But this is it's 5 marks, and anybody can learn how to do this. So make sure you go into the exam knowing how to do this. Anyway, let's hope I do know how to do it. So it's first step, the determinant of T minus lambda I equals 0. Write this down, you get a method mark for it. If you want to know why I'm doing any of these things, watch my video, because I'm not going to go into that much detail. I'm just going to show you how to do it. So this equals 0. Then I have to actually get T minus lambda I. So it's 0.8 minus lambda, 0.3, 0.2, and 0.7 minus lambda. So the determinant of this equals 0. Then I do this times this, 0.8 minus lambda times 0.7 minus lambda, minus this times this, so minus 0.6 equals 0. Multiply this out, 0.56 minus 0.8 lambda minus 0.7 lambda is minus 1.5 lambda, plus lambda squared minus 0.6 equals 0. And then, well, I'll just simplify this a little bit. I have lambda, let's go up here, lambda squared minus 1.5 lambda minus 0. I'm just looking at something seems wrong here. Minus 0. Yeah, sorry, that's 0.06, guys. 0.06. So that should be 0.5 equals 0. I nearly made a mistake there. Okay, anyway, don't try and solve that any way other than the calculator. So calculator, polynomial tools, roots of a polynomial, degree 2, real, 1, and 1, negative 1.5, and 0.5. Press enter. 0.5 and 1. Therefore, lambda equals 0.5. Are they both positive? Yes. 0.5 and lambda equals 1. So these are the eigenvalues. Let's start with lambda equals 1. For lambda equal 1. Okay, so to get the eigenvectors, we have to say t, well, t 0.8, 0.2 times 0.3, 0.7. This times, let's say xy, has to equal lambda times xy. And then we have 0.8 x plus 0.3y has to equal x. 0.3y equals 0.2y, and y is equal to, 0.2x. That's my x minus 0.8x. And then my y equals 2 over 3x. The eigenvector is then, well, it is 1 and 2 over 3. You can think of it like that. Or a better way to do it, or a nicer eigenvector, would be let's multiply above and below by 3, or both. Let's multiply both by 3, because as long as it's going the same direction, I can use that as my eigenvector. So I'm going to multiply this by 3, which is 3, and this by 3, which is 2. So my eigenvector, don't write that equals because it doesn't equal, but I can use any eigenvector, but I'm going to use 3 and 2. Okay, for lambda equals 0.5, same thing, 0.8. Well, I don't have to write this out again. I'll just do 0.8x plus 0.3y equals 0.5x. 0.3y equals minus 0.3x. So y equals negative x. So our eigenvector, this is an easy one, eigenvector is 1, negative 1, or negative 1, 1. So let x is 1, y is negative 1. Here, let x equals 3, y equals 2. Okay, so if you want to write down the answer clearly, lambda equals 1 and 0.5, and with corresponding you could even write eigenvalues here if you want, whatever, eigenvectors. Just be clear which is corresponding to which. So the 3, 2 corresponds to the lambda equals 1, and the 1, negative 1 corresponds to the 0.5. Okay, done. That's parts A and B.